The headline reads "No safety tests," but the engineering reality is a massive shift in responsibility. If external gatekeepers vanish, your MLOps pipeline becomes the only barrier between production and liability. This isn't about politics. It's an architectural crisis where developers must stop relying on vendor promises and start building their own inference safety rails for open-weight models. When regulators step back from testing open-source AI, the question that matters for most teams is not whether a model passed a government checklist. It is who stops you from getting sued when that model decides to generate harmful content or leak proprietary data during an agent's autonomous execution. The shift from safety-first mandates to rapid deployment forces engineers to treat safety as code, not policy. Recent convenings involving over 45 experts confirm what many practitioners already suspect: centralized gatekeeping is insufficient for the scale of open-source adoption we are seeing today. As the industry pivots toward deploying foundation models without external validation, a consensus has emerged that safety must become an engineering imperative rather than a simple compliance checkbox. This means your role as a developer is expanding beyond integration to becoming the primary architect of compliance for your organization's AI stack. The fear driving this shift comes from hard data showing how easily current safeguards can be bypassed. An external audit by Mondragon University tested the OpenAI o3 mini beta using over 10,000 automated unsafe prompts across 14 high-risk categories. The results were stark: safety filters were successfully bypassed, and auditors identified 87 confirmed instances of unsafe behavior in a dataset that was supposed to represent state-of-the-art protection. This failure rate proves that even models marketed with safety-first branding have significant gaps when faced with novel attack vectors like prompt injection or compositional failures. Relying on post-deployment fixes is now considered dangerous for open-ended systems, which are capable of indefinite self-evolution without fixed goals. These agents introduce unique risks like emergent misalignment and a loss of predictability that static safety frameworks simply cannot handle. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. When you choose an open-weight model for production today, the cheap option that requires no external testing is often the most expensive in terms of operational risk management. You must factor in the cost of building your own inference safety layer because the model itself can no longer be trusted to be safe by default. The engineering reality demands a move toward deliberative alignment, where reasoning happens before responding, and custom monitoring layers are integrated directly into your inference pipelines. To mitigate these risks without external oversight, you need specific architectural patterns that go beyond basic input validation. One critical approach is implementing structured context management to prevent agents from improvising unsafe actions in uncontrolled environments. This involves setting up parallel sub-agent isolation tools so that if one component drifts into risky behavior, it cannot compromise the entire system or execute unauthorized commands on your infrastructure. Another essential control is automated stress testing pipelines similar to Astral, which simulate adversarial attacks before a model ever touches production traffic. These systems continuously probe for vulnerabilities and force the agent to resolve ambiguity safely before generating output. By embedding these checks into your MLOps workflow, you create a dynamic defense that evolves alongside the models it protects rather than relying on static rules written months ago. The technical shift here is profound. The "it works on my machine" approach is dead for open-weight models in production environments. You need to implement agentic safeguards against prompt injection and multi-agent context isolation tools like OpenCode or agent memory to ensure agents don't drift into unsafe behaviors during execution. This level of engineering rigor transforms safety from a passive expectation into an active, measurable component of your deployment strategy. This expansion of responsibility changes the career trajectory for software engineers working in AI. You are no longer just a model integrator. You are now responsible for building the guardrails that prevent legal and operational failure. If regulators step back, you must build the safety layer around the model because the model itself is insufficient to guarantee safe behavior at scale. The consensus among experts, including 96 authors of recent international AI safety reports, is clear. safety must precede deployment for open-ended agents. Relying on post-deployment fixes is dangerous when systems evolve beyond their initial design parameters. The 30 report authors nominated by major international bodies like the OECD and EU emphasize that ecosystem-wide infrastructure requires engineers to take ownership of these risks through code rather than waiting for policy updates. As you evaluate new tools or models, ask yourself what happens if your external vendor stops providing safety guarantees tomorrow. If they did not provide it today, can your stack handle the load without breaking? The answer determines whether your organization is prepared for a world where every deployment requires an internal audit of its own logic and constraints. The path forward involves treating inference safety as a continuous engineering challenge rather than a one-time certification event. You must build pipelines that detect emergent misalignment in real time, isolate risky subagents instantly, and force the system to reason through potential consequences before acting. This creates a robust environment where innovation can proceed without sacrificing operational stability or legal compliance. The tools exist today to enable this self-built safety rail approach for those ready to upgrade their stack. The difference between a successful deployment and a costly incident lies in whether you have built these defenses into your core architecture from day one or tried to bolt them on after the fact. Your team's ability to implement deliberative alignment and automated stress testing will define how safely you can scale AI capabilities in this new regulatory landscape. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.